Hi friends, today we are going to do another Leetcode problem, which is container with most water. This is a very interesting problem. So in this you have been given a variable height, such as here 186254837, and you have to find out the maximum level of water, basically the maximum area which it can hold. So to give you an example, over here it has actually plotted the same height bars over here, like 186254837, and now the maximum what area it can hold is this, which is the minimum of these two bars, as 7, and then multiplied by this. Now it can also taken, so that's going to be 7 as the height, and then um, the width is going to be again 7, which is 1 2 3 4 5 6 and 7. So 7 into 7, your output should be 49. Now let's look at this bar also, because this is again 8 and 8. So very you could take this also as a solution. So if you have 8 over here as the height, but your width will be 1 2 3 4 and 5, so it's 8 into 5 40. So it is a lower number, so you want to send the maximum area that it can hold. So let's first try and understand the intuition behind this problem, and then we'll solve this problem. So I'm going to share two solutions. Let's just dive into them. So just for simplicity's sake, I have already taken the height over here, which is 186254837, and I've already drawn the graph for you. Now let's first try and understand, how do we actually calculate the area, and what are the two things that, we really need to maximize on. So for example, if we have a rectangle like this is going to be our x-axis, and this is going to be our y-axis. So an area is x into y. So we need to understand this concept, because remember when we were talking about earlier, so we calculate the area by x into y. Now we want to maximize the height of x and y. How will we get y? So basically that is the distance between any of these two heights. So for example, if my pointer is at one pointer is at 8 and the other pointer is at 7, if I just minus 8 by 1, which is 7, I'm going to get the answer for my y. Now for my x-axis, I have to take the minimum height of these two, and that's going to be my x-axis. Reason being, if I have one, say for example, one height like this, and then this is my y, and then this is my x. So I cannot take water like this, right? Anything above this level is going to basically flow out. So this has to be my x, which is the minimum height of these two bars, and then y is the distance between these two bars. That's how I'm going to calculate. So one very easy solution for this is going to be backtracking. Now what is backtracking is that for every point, you basically calculate the area for all the other points, and then basically store it, and in the end you take the maximum value. So to give you an example, I'm going to have two pointers for this. I'm going to start I from the very first position, so it's going to start with value 1, because at 0 index I have one value. And for j, I'm going to start as the next value from 1, which is going to be 8. um, from 8, and then I'm going to basically calculate the area. So I'm just going to have a list which will store the area for me. So for here, if I see 1 out of 8, um, minimum is 1, so that's going to be my x, and y is going to be 1 because there is only one difference over here. So 1 into 1, my area becomes 1. Now my j pointer is going to move to the next bar, so it will become 6. Now my area is going to be 1 into 2, so my area is 2. Now my j is going to move to the next bar, then it will become 2. Again minimum is continues to stay 1, so it's 1, but my y-axis has moved by up by 1. Now I have 1 2 and 3 as the distance, so it's 3 into 1 as the area, so it's going to be 3, and so forth. So once I have completed the loop for j, I'm going to increment I to the next pointer, so I becomes 8, and then my j will start um, from the next element, which is going to be 6 after 8, and now I'm going to calculate the area for this part. So for this part, my area is going to be 6 because minimum of 8 and 6 is 6, and there is 1 as distance, so it's going to be 6. And then I'm going to move again j to the next pointer, so this will turn into 2. um, and now my minimum becomes 2, and there are 2 spaces in between, so it's 2 into 2, 4, and so forth. I'm going to calculate the area for each bar with all the remaining bars till the end, and then in the end I'm going to take the maximum area. So let's look at the simple code for this, then I'm going to give you a more optimized solution for this problem. Now let's start coding for the backtracking problem. So for this, first let's take a list, which is going to be an empty list, which is going to store the results for the area at each for loop. Now let's start a loop which is going to go till the end of the height. Now let's take another element. So this I is going to be the left side, and j is going to be the right side of the bucket. So this will always be I plus 1. This will also go till the length of height. Now area will be equal to, so we'll get the y-axis by j minus I, multiply that with minimum of the height of I and the j. Now we are going to append the area to max area, and in the end we will just return the maximum of max area as the result. Now let's run this code. So as you see, it is successfully run. Now let's submit it, but unfortunately we won't be able to, because since it's looping for all the elements, it's a very time consuming process, and this will not pass the case. See, it says time limit exceed. Now let me tell you a more optimized solution for this problem. So now let's try and understand the intuition for this problem. So as you remember, I mentioned that area will is calculated x between y. So whenever our y is maximum, our area is going to be the maximum. So what we are going to do for this problem is, we are going to keep a pointer I at the first location, and we are going to keep a pointer j at this location. And now we are going to calculate the area, because our y will be the maximum for this. Now if you see for this example, my area would be the so my I, let's just keep that over here as well. So my I is 1, and my j has the value 7, and I will keep a variable area which will have the area for this. So my area will be, if you look at the places of y, how much it is: 1 2 3 4 5 6 7 and 8. So it is 8. Y-axis is going to be 8 for this, but let's look at the minimum of I and j, because as explained here, that's the amount of water that can be stored, otherwise it will flow off. So it can only store water till here, so it will be 8 into 1, so my area is going to be 8. Now I'm just going to compare I and j. If I is minimum, then I'm going to cross out I, and I'm going to move I to this location. So now my I, instead of 1, it is 8. Now let me calculate the area for this. Now if I look at my y, it's going to be 7, um, because 1 2 3 4 5 6 7 spaces are there in between. And if I look at my height, that's going to be the minimum of I and j, which is 7 in this case. So 7 multiplied by 7, area is 49, which is greater than 8. So we are going to cross this out, and my area is going to be 49. And now we are going to continue to keep doing that. Now I'll again see if my I is greater or j is greater. In this case my j is lesser, so I'm going to cross out j now and I'm going to bring j over here. Now my j will become 3. Now again I will see the area. So now my y-axis has become 1, 2, 3, 4, 5, 6, and my minimum height is 3. So 6 3s are 18, smaller than 49. So this will continue to be 49. Now again we are going to look at I and j. Whichever one is the smaller one, we are going to move that. So j is the smaller one. So we are going to move j by 1 position. Now we are again going to calculate the area. So y is 5 and both of them are at 8. So j is 8 also. So 8 into 5, 40. Again the area is smaller than 49, so we will not touch area. Now since both are same, we are just going to move I to the next position. Now I will become 6. So now my y is 4, and the minimum of I and j is 6. So 6 fours are 24, which is smaller than 49. So I will move ahead. So now my I is smaller, so I'm going to cross out I and I is going to move to the next position. So now my I will turn to 2. Now since I is 2, my y is 3 and I is 2, so 3 2s are 6 is my new area, which is smaller than 49. So I will continue to keep this as area. Now I'll move I again because that is the smaller element. So now my I turns to 5. Now my new area is 2 into 5, 10, which is again smaller. So this is going to be 49. I'm going to move I again. So now my I is going to be 4 now. Now my area is 1 into 4, which is 4, which is smaller than 49. So it will continue to be like that. Now my I cannot go any further because I need at least one space to have that bucket of water to fill. So I'm going to exit out of the loop. So now let's look at the code for this solution. So I'm going to, as spoken earlier, I'm going to keep now max area. Now this time it's going to be a variable which is going to store the maximum area as 0 for time being, and as the area increases, it's going to store that. My I element will start from 0 position, 0 index, and my j is going to start from the last element of height. Now I'm just going to loop while I is smaller than j, because remember we always need at least one space between them to have a bucket to collect water. So my condition, my formula for area still remains that. So my y is calculated by j minus I into minimum of the height for the two elements. Now I'm just going to check if my area is greater than max area. I'm going to replace max area with area. Else if I'm just going to now check the element with the smaller height. So if height of I is smaller than height of j, I'm going to just decrease j by 1, so it's going to move to one left position. Else I am going to move I to the right, and in the end I'm just going to return max area. So let's run this code and now let's submit it. So as you can see, this is a pretty decent solution. Thanks for watching.